The concepts of elasticity need to be understood as follows. That elasticity is simply the percentage change in quantity demanded over the percentage change in price. So if a question comes with a formula that you need to identify, elasticity of demand is simply a percentage change in what? Quantity demanded over the percentage change in price. So using this definition, now a question may come to say, what is the impact of a 5% increase in price where the elasticity is -2? What is the impact of a 5% increase in price and the elasticity of demand is -2? So using this definition, where there's elasticity of demand, we put -2. Then the percentage change in quantity demanded, we don't know. But we have been told that the percentage change in price is what? 5%. So we know that elasticity of demand is always negative. It comes from the demand function, which says that there's an inverse relationship. When one is going up, the other should go down. So you just cross multiply here. So 1 is a percentage change in quantity, is a percentage change in quantity demanded. And 2 times the 5% will give you -10%. So examiners will use this definition of elasticity to explain. So the answer therefore will be 5% increase in price will result into a what? 10% increase in 10% decrease in quantity demanded. Note that the negative means a decrease. So sometimes because of multiple choice, they'll put you into a scenario where you need to differentiate. What will a 10% increase in price result in? A, an increase by 10% in quantity demanded. B, a decrease by 10% in quantity demanded. C, they'll bring in other questions that will confuse you. It is a decrease by 10%. Together? So, finding elasticity of demand, as I have done, you also need to understand the factors that affect the elasticity of demand. Now, explaining elasticity of demand as a responsiveness of demand due to changes in one of the determinants of what? Factors that affect demand. Now, there are about 3 factors that affect demand. We usually terminate on 5 for elasticity. So this is called our demand function, where we are given the demand, which is the dependent variable, and the factors of that affect demand are called the independent variables. So we have 7. One of them is the price itself, X. The other one is the price of what? Complementary good. The other one is the price of a what? Substitute good. So these two will come up with what is called cross price elasticity. So the factors that affect elasticity, number 1 is the price of that particular good. Number 2, the price of related goods. Number 3, income. Okay. Number 4, what will affect the elasticity? We have advertising, maybe population, if you want. So elasticity is affected by a number. There's also place, preference, culture, etc. But I'm going to dominate on just these 4. The price of that particular good will affect the elasticity of demand. So we call that on-price elasticity of demand, or PED, because it is the sensitivity that happens within a particular commodity. In layman's language, elasticity looks at how you react when you hear that the price of one good goes up. So we have what is called price elasticity of demand. Now, for price elasticity of demand, for us to understand it further, we need to understand that there is what? A range within which elasticity will vary. We have 0, we have -1, -2. If the answer is between -1 and 0, we call that inelastic. At point A, At point B, it's called unit elastic. At point C, it is called elastic. So if they give you various questions to understand which ones of the following depict demand which is inelastic, 0.74, negative 1.74, negative 1.0, and 0.245. Which one of the following depicts an elasticity of demand which is inelastic? Who wants to try? A, B, C, D. Which one of the following depicts an inelastic elasticity of demand? To start with, elasticity of demand is always negative because of the inverse relationship. So D ultimately comes out because it is a positive. Now, any number between 0 and 1 is inelastic. So at point A is inelastic because it is 0 point something. So this is inelastic. At point B is above 1. So this is what? Elastic. At point C, it is exactly 1. This is unitary. So which points are inelastic? It is negative 0.74. So to interpret that, either the examiner would want to find out from you what is the impact of a 1/4 increase in price. What is the impact of a 1% increase in price? So this means that if you increase price by 1%, quantity demanded will reduce by 0.74%. So demand is inelastic means it's not very reactive, it is significant. So if you increase price by 1%, you release demand by 0.74%. Further on, the examiner will say, suppose price increased by 5% or price increased by 10%. What will happen to quantity demanded? Simply multiply this one by 10%. So when you multiply this by 10%, we're going to get 7.4%. So this is inelastic. Inelastic occurs when the increase in one variable results into a decrease by a lesser margin of the other variable. So here we've increased by 10%, but we are losing 7%, which is insignificant. So now I'll ask you, which of the following depict an inelastic situation? So percentage increase in price, percentage decrease in quantity. So A increased by 10% and quantity decreased by 15%. B, the price increased by 100%, the quantity decreased by 9%. And C, the price increased by 5% and quantity decreased by 5%. So which one of these following depict an inelastic situation? A, B, C, or D? A, B, C, or D?
B.
B. All right. B is elastic. A is elastic, B is inelastic, and C is what? Unit elastic. So that's on elasticity. Further on, you'll be given a diagram. So we know that good A has the following. We have price and quantity. So here, the price increased from 10 to 12/4. The quantity decreased from 500 to 300 units. to calculate the elasticity of demand. So who remembers the formula for elasticity of demand? We said elasticity of demand is what?
Change in quantity divide by change in price.
And the change in price. Okay. Now the percentage change usually is given as follows. We have Q2 minus what? Q1 over Q1 divided by new price minus the original price over the original price. We can call this original, this one is a new price. Let's calculate the elasticity of demand using the variables. Who wants to try to help us? So here, our second quantity is what? 300 minus what? Original quantity was what? 500. Divided by 500. Everything over. The new price was what? 12 minus 10. Divided by 10. So here we're going to have, what are we going to have? Negative 200 divided by 500. Here we're going to have what? 2 divided by 10. All right. So what do we get? Quickly, what do we get? On top, we're going to have
negative 2.
0.4. And below, we're going to have what? 0.2. The final answer, what's the elasticity of demand?
Negative 2.
Negative 2.
Negative 2.
What is your comment on that?
It's inelastic.
Is inelastic? Do you agree with him? Is it inelastic?
I think it's elastic.
It should be elastic.
Elastic, correct.
It's elastic. Sorry.
Elastic. Now, how will the actual questions come? They'll come like this now. So suppose price of bread rises from 4,000 to 6,000 per unit. As a result, the quantity demanded falls from 120 to 80 units. Find elasticity of demand. Who wants to try that? Lead us through.
Okay. Elasticity of demand is equal to change in quantity divided by change in price.
Okay. So elasticity is equal to change in quantity, percentage change in quantity demanded over percentage change in price.
In price.
Huh?
Yes. So which is because there is it rises from 4,000, so 4,000 becomes the P1, and the new price is 6,000.
So
Then
P1 is 4,000.
yeah,
P2
then
is
P2 is equal to 6,000, and Q1 it's 120. Then Q2 is 80. Then now we replace in the equation, that is Q2 minus Q1 over Q1 divided by P2 minus P1 over P1. which is equal to, we are saying 6,000 minus 4,000 divided by 4,000. Do everything divided by 1, divided by 80 minus 120 divided by 120. And now we compute, that is 2,000.
Sorry, just to confirm, isn't the price supposed to be lower?
Let's confirm. There's a question.
Q2, I understand, is 80, so it should be that what you've put 6,000 minus 4,000 over 4,000, it should be as the denominator. Is it numeric? What? It should be.
No, he's right. Because when you increase price from 4 to 6,000, quantity demanded will decrease from 120 to 80. You demand less.
Okay. Okay. Yeah, but what I'm saying, the formula is change in quantity over change in price.
Oh, it's vice versa. Yes, that's very true. Yeah.
But what you've done, you put the price as on top over the quantity.
Oh, okay. All right. Okay.
That's very true. That's correct. Yeah.
Okay. So, yes.
So you, in this, you are getting the inverse.
Right. Great. So, supposed to be what? Is our Q2?
So, yeah.
See?
Which is 80 minus 120 over the
120.
Yeah.
And
Yes, then
6,000 minus 4,000 over
yeah,
4,000.
4,000.
Excellent. Are we all following?
Yes.
Yes, we are.
Yes.
Okay. On top would be negative 0.33. And below 6,000 minus
0.5.
divided by 4,000. We get what? 0.5.
0.5.
We get as our elasticity.
0.666.
And 3 divided by, so we get what? 0. What? Negative 0.666.
Yeah.
All right. So what does it mean? So this question actually came from a tutorial sheet. I want you to understand what the questions in there. I'm not getting any questions from elsewhere. You are seeing them. So this is a question, the percentage change. So we calculated, although he was using a literal, it's the same thing. And you got 0.66. So what does this mean? It means if price changes by 1%, demanded will change by 0.66. So demand there is what? Inelastic. Are we together? And here will be what? Inelastic. Are we together?
Yes, sir.
So another thing we need to also know about elasticity, we already talked about the determinant, the number of closed substitutes. Okay, the importance of the commodity also will determine the elasticity.
Mr. Collins.
Yes, please.
At why is the demand inelastic?
Okay, there's a question there. Why is demand inelastic? To start with, elasticity of what? Demand is always what?
Negative.
Negative. Why is demand of elasticity always negative? Because of the inverse relationship between what? Demand and supply, because of the higher the price, lower the quantity demanded. So elasticity of demand is always what? Negative. And also the ranges for inelasticity, you need to know that elasticity ranges between what? 0, -1, -2 upwards. Any answers between this point 0 and -1? will be called what? Inelastic. Inserting the zero in short, 0 point something is inelastic, right? At exactly 1, what is it? Exactly 1, what is it?
Unitary.
Unitary.
Yes. If it's more than 1, what is it?
It's
Elastic.
elastic.
Elastic, yes. Right? So before we go to the theoretical part of it, because calculations, I know most of you will have difficulties, as we'll need you to, as much as possible, try to also verify, you know, understand the concept. All right. Any questions at this point?
Okay, so we're saying that if it's more than 1, it's elastic. If it's less than 1, it's inelastic.
Yes, yes, yes.
Okay. All
right. Any other questions? Any other questions? Okay, so now let's look at the question from the pamphlet. Those of you who have a copy, let's look at the question on elasticity. First, I'm looking for the question, what are the factors that affect elasticity? What are the factors that affect elasticity?
Is price.
Price of the good.
Huh?
Advertising.
Availability of the substitutes.
The bid of substitutes, yes.
The importance of the commodity in consumer budget.
Exactly. Right. So let's now go to other calculation. This was a test for the other index. Right here, when the price of petrol is $2 per liter, copy it here so that you can try it before we proceed. Yeah, the price of petrol is $2 per liter. Sunny station sells 5,000 liters per week. When the price goes to 1.9, we sell 5,500 per week. In the elasticity, in the midpoint method, which is elasticity. How do we compute elasticity? Who wants to try? Okay, so elasticity is about a number of formulas that you need to know. What we call point elasticity, midpoint elasticity. The midpoint elasticity is simply given by the following formula. Number 1, elasticity of demand is equal to Q2 minus Q1 divided by Q2 plus Q1 over 2. What's the average?
Mr. Collins,
Yes, please.
I think Dr. Chonzi is just saying that the test has been postponed. He's unwell.
Cancelled.
Oh, yeah?
Mm.
That's good news, isn't it? This is a midpoint method. So if you're using the midpoint method, the formula is simply Q2 minus Q1 over average. This is Q2 plus Q1 divided by 2, divided by P2 minus P1 over the average of the price, P2 plus P1 divided by 2. So we know this is the elasticity, and we know the elasticity ranges as prescribed. Now, elasticity, on the other hand, has, we're talking about 3 types of elasticity, all right? So we have 3 types of elasticity. Number 1, the type of elasticity, which we're just from looking at, is called the price elasticity of what? Of demand. Number 2 type of elasticity we need to know is cross price elasticity of what? Demand. And number 3, we have the elasticity which is called the income elasticity of demand. There are just 2 principles you need to know from each of them. This one here, you just need to know the ranges of elasticity. When elasticity is greater than 1, say this is what? Elastic. Elasticity is equal to 1. This is called unit elastic. Here, when elasticity is less than 1, it is inelastic. Now I'm putting absolute figures here to assuming that these are negative values, so we equal that. Cross price elasticity, if it is negative, we say this is a what? A complementary good. If it is a positive, it is called a what? Substitute good. That's all. And when we go to time elasticity of demand, we have 3 ranges. For 1, we have a negative. We have a negative, it's called inferior good. All right? When it's between 0 and 1 or going upwards, all these are called normal good. But the normal good, we have 2 categories. Between 0 and 1, it is called a necessity. Above 1 is called a what? Luxury. Now, before I go into the calculations, I need somebody to help me find these types of goods. What is a complementary good and what is a substitute good? What is a complementary good and what is a substitute good?
So can I try?
Yes, please.
Okay, so complementary goods are those goods that go together, like butter and bread, for example. And then substitute goods are those goods that can easily be replaced. Like you can replace one for the other. For example, I think this is where Coca-Cola and Pepsi come in. You can drink, like if you drink Coca-Cola, it can also give you similar.
Excellent. Okay. So Coca-Cola and Pepsi, those are what? Substitute goods. They're also called competing goods. So substitute goods are competing goods. Complementary goods are goods which complement each other. They move hand in hand. One is useless without the other. All right? One is useless without the other. They move together. Car and fuel. So complementary goods have a negative relationship because if the price of fuel goes up, you will not buy the fuel. You also not buy the what? The car. So a price increase in fuel will result into a decrease in demand of the cars. But for substitute goods, the price increase in one will excite the other. So if you increase price in a Stakenic or cinema, especially cinema will be excited, the demand will go high for the other. We go to income, which is denoted by Y, M, or I. So this one, this category here, if you find a negative, the good is called an inferior good. If you find a positive, it's a normal good. Between 0 and 1 is a necessity, above 1 is a luxury good. So, what is an inferior good? Inferior good is a good whose what? Demand will usually go down as your income goes up. If income goes up, you buy less of that particular good because it becomes inferior. A good example is Salaula or a black and white TV. When you have enough money, you go for a plasma, you go for flat screen, right? So you demand less of a good, not because you can't afford it, but you can afford better. So a necessity is between 0 and 1. A luxury good are good that we can do without. So a company, the following demand function. Coca-Cola. I told that they had 5 minus 6 price of Coca-Cola. Then
Hi, Collins. Just a second.
please.
Are you able to just take back? I didn't take the range on the income elasticity.
So for income elasticity, I said there are 3 categories. If you get a negative, it's got an inferior good. So if you get -2 as your income elasticity, say you know that is an inferior good. If you get 1 or 0.2 is a necessity. It's a necessity. Necessities fall within food, shelter, the basic necessities, what we need. If your elasticity of income is 1.7 or even 2.5, you just know that this is a luxury good. A luxury good like aircon, Bugatti, and other things that we, or ST, we can do without. So, in short, there are 2 streams. There's an inferior and a normal good. But under normal, we have subtitles of necessity, luxury. Is that clear?
Thank you so much. It's clear.
So here we have Coca-Cola company has what? The following demand function. 2C equal to 5 minus 6PC plus 4 Pepsi PP. Okay, minus 2Y plus 10A, where A is advertising. Maybe advertising was kwacha, where income maybe was 10 kwacha, and the price of Pepsi was 5 kwacha, and the price of Coca-Cola was 4 kwacha. So we're being asked to calculate and comment on each of these elasticities. So to find the current demand for Coca-Cola, they substitute the actual prices there. We put a 4 where there's Pepsi. Here we put a 5 where there's 4 where there's Coca-Cola, 5 where there's Pepsi. And the income, we put a 10. And here we put a 2 where there's what? Advertising. So to calculate, we need to substitute these variables to get the value of what? Of the current demand. 5 minus 24 plus 20 minus 20 plus 20. We're getting 1. This is correct. So this is 24. Yes, so we're going to get 1 as the current demand. So you ask you, but A, find the price elasticity of demand. Price elasticity of demand is simply gradient of this called B times the price of Coca-Cola or the quantity of Coca-Cola. This is called on price because we're dealing with one commodity. So the gradient for Coca-Cola was what? 6 negative. And the price for Coca-Cola was what? 4. And our current demand is 1. So when you multiply this, we get negative 24. So negative 24, it means the demand is what? Very elastic. And we go to the next type of elasticity, which is cost price elasticity. It's simply the gradient and the price of the other good, it's Pepsi, over the current demand for Coca-Cola. So it's called cross price elasticity because it's crossing from one good to another, from Pepsi to Coca-Cola. So the gradient for Pepsi was what? 4. And the price for Pepsi was 5. And the current demand, we found 1. So when we multiply this, we get positive what? Positive 20. And we know that when we get a positive cross price elasticity, it means these are what? Substitute. So if it was a negative, we would have said this is a what? A complementary. But Pepsi and Coke compete against each other, they're substitute goods. Then when we go to our last, which is the income elasticity of demand, we go to the gradient for income, the actual income over the current demand for the Coca-Cola. So the income, what is the gradient for the income? We have a 2. And the price of income, we have what? 10 over our current demand, which is 1. Here we get what? Positive what? 20. So what kind of good is this? It is a what? It is luxurious good because it is exceeding the range of 1. So this is a what? A comfort good, luxurious good. If we got 0.2, we would have said this is a what? A normal good. If we got negative 20, we would have said this is an inferior good. This is, say, trying to make you understand how to relate these goods in terms of their elasticities. Are we together? This is now trying to relate this according to their elasticities. So this question was also brought in your tutorial sheets. Like I said, you need to make sure that you go through all your tutorial sheets. It will be very important, very vital for you. So any questions before I proceed? So you'll be given a question dealing with cross price elasticity as follows. We're dealing with shoes here. This shoe has the following demand function. Now, I'll give you a secret. These two goods, you know that they're related goods. The signs are different. One is negative and one is positive. That's not automatically that these are what? Substitute goods. They're competing. But if there was a negative here and here's a negative, that's not that these ones are what? Are complementing each other. Or positive here and positive there. The same sign, but complementary. All right? So we have the variables here. The price of good X, the price of good Y. M stands for the income, advertising. So we are told that 25 is the price of good X, whereas 35 is the price of good Y. 50 is advertising, and 20,000 is your income. So quickly tap, add these figures in here. Get the current demand. So 65 is the current demand. Here, don't even need to use any calculus. It's quickly. The on-price elasticity demand, just use X against X, X against X. So there's a 3 here. So we're going to get a gradient. 3 times the price of X was 25 over the current demand 65, which we've calculated. So 3 times 25 over 65, negative 1.15. What's a quick comment there? Elastic or unit? What is a quick comment? Elastic or unit?
Inelastic.
Elastic, is it right? Is it right? We're following. It is elastic. Inelastic is always starting with a 0. All right? Inelastic starts with a what? A 0. Elastic starts with a what? A number. All right.
Noted.
Now go to the other one. We're dealing with cross price elasticity. It's dealing between X and Y. Get the gradient of Y, which is 4, 4 times the price of Y was what? 35. So 4 times 35 over 65, which is what? So 4 times 35 over 65 will get what? 2.15. The answer positive or negative? Answer positive or negative? It's positive. So what is our comment when the elasticity is positive for elasticity? Cross elasticity. You want to know whether it's a substitute good or a complementary good. So since our answer here is positive, what is our comment?
It's a substitute.
A substitute good.
A substitute good. So so a substitute good has a positive elasticity. Complementary good has a negative elasticity. Okay. So we now go through our income elasticity. Income elasticity, we now go to calculating our values there. So the gradient here is 0.1 times the price of the income, 20,000 over 65, which was our current demand. So 0.01, 20,000 over 65, and we're getting a negative. Yeah. All right, so what is our comment? This is negative, it's an inferior good, correct? It's a negative, we comment that this is an inferior good. Now examiners, let's go to the pamphlet now. Pamphlet, examiner would want to ask you questions to do with elasticity too. So here's a question to say, in case of normal good, income elasticity of demand is positive, which means increase in income will increase demand. In the case of inferior good, income elasticity is negative. An increase in income will lead to a fall in the demand of inferior goods. So if our elasticity is negative 0.4, it means that is income elasticity of demand. So that is an inferior good since it is negative. And they ask you if you get 2.8, what is this? This is a normal good. Precisely, it is a comfort good, a luxurious good because it's positive. When we get negative 0.3, this is an inferior good because it is what? Negative. When we get negative 3.4, still an inferior, very inferior good since it's what? Negative. How about if you get positive 0.6? It becomes a normal good, but precisely necessity. You getting that? This one is what? Necessity. Anyone behind so far? Anyone behind so far? Are we moving together?
So far, so good. I just wanted to find out if that's a standard formula that was in the question for the one that was given. Is it always the same or they do change?
It's usually same unless we're using calculus, but it's usually the same.
Oh, for linear. Okay, linear and calculus are two different. Okay, I understand.
Yeah. Okay, so this will be homework. Most of you did this homework already. So elasticity, I think this is how I can. Yes.
I haven't seen when it's a luxurious good. Is it positive or negative?
It's positive, except that it is what? More than one. So
more than one.
Yes, the elasticity. So which one is a luxurious here? Okay, which one is a luxurious? Luxury. This one is what? Inferior. This one is what? Inferior. Inferior. This one is a normal good, but it's a what? Necessity.
Okay.
Okay. So I hope we're moving at the same page. I'm trying to simplify this as much as I can so that I don't leave anyone behind. I'm trying to really simplify this. So we now go to the issue of what? Demand. So demand, we said, has a rule. The rule is that demand follows negative sloping. Supply follows up sloping. Collectively, these two will meet at a point where they both agree. What is that called? Point where demand and supply meet, what do we call that?
Equilibrium.
Equilibrium point.
Equilibrium point, correct. So at this equilibrium point, demand meets supply. So this area here, area A and area B. What is area A called? Consumer surplus. And what is area B called? Producer surplus. And the formula for each of these ones is equal to what? Half base times height. Half base times height. Are you following? So
Yes.
I need to teach you basics of illustrating what we call linear equation. So if you're given a demand function, which is as follows: n minus 2q. So this is called the inverse demand function because the demand function starts with a p. So you put the letters on one side, this will be p plus 2q to give us 10. Then you identify the coefficients, the numbers that are before the letter. 1 into 10 is 10. 2 into 10 is 5. And whenever we are plotting on an XY plane, our P is always here and our Q is always here. So P cuts the axis at 10, Q cuts the axis at 5. So just join the two lines. This becomes your demand function, which is the P is equal to 10 minus 2Q. So sometimes you may be given the direct demand function, which is 10, 100 minus what? 5P. Who wants to help us illustrate this function? Yes, Alice. Put the letters on one side. What do we have? Anyone else? Q is equal to?
Q plus 5P equals to 100.
The intercepts?
Q over under Q, it will be 100 since there's one here. We assume there's one into 100, it will be 100. Then on 5P, it will be 5 into 100, it will be 20. And then P on the, yes, and that. On the P, it will be 100, or at 20, sorry. And then on the quantity, 100 to meet 100.
Excellent. Do we agree with her? This is how we plot.
Yes.
On the other hand, supply is up sloping. So if you have 10 plus 2Q. So let's put the letters on one side. What do we have? P minus 2Q equal to 10. Intercept, 1 into 10 is positive 10. Negative 2 into 10 is negative 5. So the X or Y plane will present our following results. We're going to have negative 5. And here you cut at 10. Although we have no negative quantity, preferably this would look like this, just start at 10 going upwards. So this is our supply, which is P is equal to 10 plus 2Q. All right. Obviously, you would also be given the supply in terms of what? In terms of direct supply function. So we are going to have the negative 3p negative 3p plus 12. All right. And also we're going to have qs is equal to 3p minus 12. So I need you to identify which one of these two is a demand function and which one is a supply function. Which one of the two is a demand function and which one is a supply function?
So the second one is the demand function and the first one is the supply function. Because the demand function has a negative gradient.
Okay. So this one is what?
The demand function.
Demand function. This one?
Supply function.
Supply function. Do we agree?
I guess they're supposed to be. The first one, I think it's a demand function.
Demand function. Then this one?
Right. Yeah, that one is what I'm lost.
Okay, let's try to illustrate them. Put the letters on one side. Q plus 3p is equal to what? 4. All right. So that's here. There's a 1 there. 1 there is what?
12.
4. 3 in there?
4.
4. All right. Here we put this on one side. So we're going to bring the 12 this side. 12 will be positive if you want. And here we're going to have 3p minus 1 q. Understand this movement? 12 ngayoku are positive. 3p are actually fine. The q coside subtract. Together. We together?
Yes.
Yes.
Yes, so we now start the intercepts. What number is on the P? It's a 3. 3 into 12? 4. What number is on the Q? Negative 1.
1.
Negative 1, 12, negative 12.
Negative 12.
So you can call this A, this B. Let's sketch these ones, A and B. Okay. So our A, our B here. Our A, we have 12 here, 4, and here 12. Here we have what? P and Q. We have negative what? 12. And what? And 4 here. Which one is supply? Which one is demand?
A is demand and B is supply.
All right. So the gentleman, although he was guessing, he was right.
Oh, I was not guessing on the first one.
Oh, you're not guessing? All right.
So for me, Collins, I took it that you get it just from the same equation there.
Yes, you can
So
tell.
you see which one.
The negative gradient. gradient here is negative.
Okay.
So demand. The gradient is simply the intercept of the what?
Okay. Thank you.
Right.
Mr. Collins, please come again on how you tell that this is a demand, this is supply function.
So we've used two methods using the graph. Supply is upsloping, demand is downsloping. Right? So you sketch them. By sight, the gradients. If the gradient is negative, we know that.
Mr. Collins.
Yes, please.
You say that demand is what sloping?
Downsloping.
Downsloping.
Upsloping. Yes.
Supply is upsloping.
Yes, yes.
Oh.
So now we want to go to some interesting calculations here. So suppose we're given our demand function as 100 minus 3Q. Our supply function is 10 plus Q. So we're going to equate these ones here. What happens at equilibrium? The price demanded is equal to price supplied, or demand is equal to supply. All right. So under demand, we're going to say 100 is equal to what? 3Q. All right. And under supply, 10 is equal 10 plus what? 2Q. So we're going to sketch these two. We're following. These are demand and this one is our supply. Together?
Yes.
So 100 minus 10. Then the letters go on one side. We're going to have 2Q plus what? 3Q. So here we have 90. And here we have what? 5Q. When you divide by 5, we're going to have equilibrium. What? 18. Right together. Then we substitute this 18 in any one of these two to get our price. So 10 plus 2Q. So where there's Q, we put what? 18. So here we're going to have 10 plus 36. So we're going to have what? This is 36 plus 10, which is 46. So our equilibrium look like this. Our demand and our supply and our equilibrium. Our equilibrium quantity is what? 18. Our equilibrium price is 46. Now, how do we sketch these? We have two different easier ways. Using the long method I showed you, which is the surface, right? Or just get the intercepts. Where there's demand, which one is a constant? 100. So demand is downsloping. Demand is downsloping here, we put 100. When we go to the supply, which one is our intercept? 10. So since supply is upsloping, we have 10. We have two areas, area A and area B. Area A is called our consumer surplus. Area B is called the producer surplus. So we need to identify the dimensions that we have in here. So we have what? Following dimensions. Number one, distance from here to here. Distance from here to here. The distance from the S from here to here. So what are these distances now? Okay. Is that is what's the distance here?
54.
4. And here? 6, and here
36, 18.
So to find this, what is the formula for the consumer surplus?
Half BH.
Yes. Right. So our base is what?
54. Or is it 18?
18.
18.
And our height from here to here?
54.
54. All right. This is called the producer surplus, which is given by half BH. So this is what? Still the same 18. Our height is what?
36.
36. So what we find here, what we find there?
486.
486. And what we find down there?
This is 04.
And what?
324.
324.
Oh.
324 is what we find. So when we total them up, we get the total
810.
810. What's the 810 code?
Total.
No?
Total surplus, is it?
For what?
Yes, I can.
Social welfare.
The before line.
Right. So we do it when we are in the physical classes. Just point out, pair you up so that you now try this example. But individually, I want you to find the consumer surplus, the producer surplus, and the equilibrium for this. Your tutorial sheet, I want you to try to find consumer surplus and the equilibrium. Are you able to try that?
Yes. Yeah, so for me, immediately I converted those, that equation. I said 20 minus 2Q.
So at equilibrium, so since we want to calculate equilibrium, what happens at equilibrium?
Demand is equal to surplus.
The supply. So what is our demand?
Our demand is 20 minus 2Q.
What is our supply?
4 plus 2Q.
Correct. So what do we do at this point?
Yeah, so we bring the numbers together. The figures that have, yes. Yeah, and it's equal to 2 plus 2Q plus 2. Yeah. So I found 16 equals to 4Q. I divided by 4 on both sides. Then I found 4.
Excellent. So
yeah. So I was wondering.
It's got to 4.
So I was wondering what that 4 is. Huh?
What the equilibrium quantity? It's Q.
Okay.
Next, who wants to continue? Another lady to find. Me, I'm very happy with the way you've grown.
So then we substitute the quantity in either the demand or supply to find the price.
All right. So let's try the supply. It's usually easier. So what do we put in the cube?
So that would be 4 plus 2 multiplied by 4.
You get what?
So 4 plus 12, 4 plus 8, that's 12.
12. Is she right? So this is our equilibrium. So this is 12. All right. Who wants to take over? A gentleman now. How do we sketch? Gentlemen, how do we sketch?
Let me try.
Huh?
I want to try.
Sure.
So where do I go? I request for remote control, is it?
No. Just say.
How do I do it? Oh, okay, no problem.
Uh-huh.
So sketching, we have the price axis,
Mm-hmm.
and then the output axis, the quantity.
Mm-hmm.
So for the demand curve, it goes downwards. It's down sloping.
Mm-hmm.
Yes. And then for the supply, it goes up.
Mm-hmm.
Yeah. So looking at our equation, so this equation for the demand, we have 20 as our intercept there. That's a constant. So we have our point there as 20.
So 20 here.
That's it. On the top, yes. And then since we found that the equilibrium price, according to the calculation, is 12, so we need to put the 12 in the middle there.
Mm-hmm.
Yes, and then the equilibrium quantity down there should be 4.
Okay.
Yes, and then when we get the supply function, we notice that the supply function, that the constant is 4. So the price at the bottom there should be 4.
Mm-hmm.
Yes, and then this demarcates the 12 in the middle, demarcates the producer's surplus at the bottom, and then the consumer's surplus at the top.
Right. Correct. Thank you. Next, somebody also take over, calculate the consumer surplus.
So before that, Collins, where does at what value is the demand curve hitting the quantity?
It's not really important here because we're not using the calculation. But nonetheless,
okay,
we're just dividing 1 into 20, that's 20. 2 into 20, 10. Same here, 1
okay.
into 4 is 4. Negative 2 into 4 is negative 2. So it's starting at negative 2. We may not even need this point at all. All right.
Okay, thank you.
So who wants to take us through now the consumer surplus and producer surplus?
So the consumer surplus is the area of triangle A.
Okay.
So use the formula alpha BH.
Correct. So let's identify what is our BH, what is our B. Base from here to here.
So the B there is 4.
Correct, 4.
Yeah, and the H is 20 minus 12, which is 8.
Okay. Then even here, we have 8, right?
Yeah.
So here we have half times what? 4?
4 times
8.
8.
What we get?
So giving us 16.
Right, and the producer surplus?
Producer surplus is the area for triangle B, which is the same formula. The base is the same, and the height is the same.
And the value,
so that gives us 16.
The value here, but also take over. Total value is going to be called what?
Social welfare.
Yes, a social welfare or what?
Surplus.
The total surplus, which is what? 82. All right. So let's mark ourselves. Since this was an example, let's verify our answers. So we are told we calculated our equilibrium price as 12 and our equilibrium quantity as 4. Is that what we got? Yeah. The consumer surplus as 16 and the producer surplus as 16. Is that what we got?
Yes.
Yes.
And the social welfare as 32. Is that what we got?
Yes.
So take note, you're able to answer these even without the graph, but the graph simply simplifies your what? Your understanding. If you're going to take this, you would still get the full marks. Obviously, I encourage you to do graphs. Economics is about graphs, right? Any questions this far before I proceed? Any questions this far before I proceed? Right, now, government intervention also involves what we call the following. So government would want to regulate the black market to avoid exploitation. You know how you will discover that when you go into the black market, you know what the black market is, right? Prices are so much unregulated. You're going to find people who overprice things and underprice things. So they'll come up with a mechanism that will control pricing, with government interventions. So the highest price above which you should not sell is called price seal. So maybe here you have 100, the equilibrium maybe was 46, and the equilibrium price maybe was you're told don't price above 50, and don't price below 40 here. And here our equilibrium here maybe was 18, and this one maybe takes you to 10. So already we know that this is what our equilibrium. Our equilibrium is already here. All right. So we had the initial diagram as follows. After introducing a price seal, government says it should not exploit people. Charge above 50, and this will take you to an optimum quantity of 10. Then also don't charge below 40. So this graph here, which has X and Y, is called our deadweight loss. So we can use the numbers there to calculate the deadweight loss, and use those numbers to also calculate our what? Use those numbers to calculate our deadweight loss, and use those numbers to calculate our consumer surplus and producer surplus. So this area X and Y, we're going to illustrate this. For X, distance from here to here is 4. The distance from here to here is 8. When we go to this one, our Y, this is the same 8 from 10 to 80. This is 8. From 46 to 40, this is 6. So the area of this one is the same half H. So here we're going to have our base as 8 and our height as what? 4. So this one is giving us 16. Similarly, the same formula here applies. Our base is what? 8. And our height is what? 6. So we're going to get 24. And up, we're going to get a 40. So 40 is called our deadweight loss. So deadweight loss is a very important principle in economics, because it is a cost to society which is usually created by what are called market inefficiencies. These ones come about because of our equilibrium, also caused by efficiencies that are caused by the price seal and the taxes that government brings about and the subsidies. So it is actually the difference in production and consumption at any given point, including a government tax. A deadweight loss is a cost to society. So the question now may come in this form. Say, assume there's a price seal of what? 10. I ask you to calculate the deadweight loss. The same question that we're just from answering will be that the price ceiling is 10 there. So what is our deadweight loss? So of course, it is a little bit complex in the sense that it will now require you to put this 10 that you have here, you put it in this supply function to give you another quantity which you substitute in the demand function. So the 10 here, we put it in this supply function. What is the supply function here? P is equal to what? 4 plus 2Q. Given us the price CO of 10. So where there is P, what we put? We put 10. We're going to have 10 is equal to 4 plus 2Q. So on the 4 opposite side, subtract, it will give us 6 is equal to 2Q. And when divide both sides by 2, we're going to get our Q. CO, we're going to have a 3. So when you hit it here, you hit here at 3. And these 3 now, you put it in the what? Demand function. Our demand function was 20 minus 2Q. So where there's Q, we put a 3. So you put a 3 there, it will be 20 minus 6, which is 14. So this will come at 14. So if I had to redraw this, we could have 14, 12, 10. 14, 12, 10, then 3 and 4. 14, 12, 10, 14, 12, 10, and this will be at 3 and 4. To calculate the areas of X and Y, half BH. Our base is the distance between 3 and 4, which is A1. And our height, the distance between 12 and 14, which is a 2. When you apply this, we're going to get 1. Similarly here, half BH, our base is the same 1, and our height, the distance from here to here is a 2. So when you calculate that, we're going to get a 1. So totaling this up, we're going to get our deadweight loss, which is a 2. So 2 is a deadweight loss. This is complex, I know. But you need to just understand what I've talked about. The implications simply come about in you understanding when to replace what. Are we together?
Yes.
All right.
I'm a little bit behind there.
Yeah.
I'm also lost, Collins. Can you explain more on how we're getting? Is that 1 as the base?
All right. So the question will be as follows. Suppose the price is equal to 100 minus what? 3Q. And we are told that the price here supply is 10 plus 2Q. We are told that government has put a price seal of 50 part. Don't charge above 50 part. You asked to calculate the deadweight loss. To start with, how do we sketch this? We know that demand is downsloping and supply is upsloping. All right. And this is the equilibrium. Are we together so far? This is price and this is quantity.
Yes.
And the intercept for demand is 100, so we put 100 there. The intercept for supply is 10, so we put 10 there. Are we together so far?
Yes.
Equilibrium is when the demand is equal to supply. When we put these two, we already did this. What was our equilibrium? We calculated as what? 46. All right. So this was the question we did here. Our equilibrium was what? 46. And our equilibrium quantity was what? 18. So to save time, this is 46 and this is 18. Are we okay with this?
Yes.
Yes.
So now government that says don't charge above 50. So you put your 50. Where's the 50? Above 46. So you put your 50 here. You cut there, you put 50 there. So this is our demand function, which was what? E is equal to 100 minus what? 3Q. So They've given us the P of 50. So here where it's P, we put 50. Right, so we calculate our what? Our Q. When the Q goes this side, it will be positive. When the 50 goes subtract from 100, get what? 50. So 50 divided by 3, our Q becomes what? 50 divided by 3, our Q becomes 16.67. Are you okay with that? So we can drop this one here, becomes 16.67. We also need to know the floor price here. How do you know the floor price? This is our supply function. What's the supply function? N plus 2Q. Where there's Q, we're going to put what? 16.67. Okay. So we're going to get 43.33. So this is going to be 43.33. So we're going to redraw this one here. This is our deadweight loss. So from here, from 46 to 50, what is it? 46 to 50, what is the distance?
4. 4.
4. And 43.33 to 46?
2.7.
2.67, correct. And 18 minus 16.67?
1.333.
1.33, correct. Now our deadweight loss is half DH. Our base is 1.33 and our height is what? 4. Okay. So this one will give us 2.66. And here our base is 1.33 and our height is what? 2.67. When you multiply this, we're going to get what? 1.77. When we total them up here, we're going to get 4.44. So this is what we call our deadweight loss. This is what is going to be called our deadweight loss. Are we together now?
Yes.
My people perished because of what? Because of lack of knowledge. Otherwise, this is basically government intervention. Finally, we go to what we call optimization. Total revenue is equal to price times quantity. Average revenue is equal to price, or is equal to total revenue or quantity. Marginal revenue is equal to change in what? Total revenue over change in quantity. Now, given a price, 100 minus what? 4Q. How do you find the total revenue? The price times quantity. So 100 minus 4Q. You put a Q there. So when you multiply this, you're going to get 100Q minus 4Q squared. This is called our total revenue. Our average revenue is simply the price. It's the same if you don't want to think too much. Our price is what? 100 minus 4Q. So if you want to show you're working, you divide this total revenue by quantity. Our total revenue is what? 100Q.
I can give you the keys.
minus 4Q
Keep
squared.
themselves on it.
So you divide both sides by what? By Q. This will just give you 100 minus 4Q. So this is called our average revenue. And how do you find the margin revenue? The margin revenue is simply A minus 2BQ. If you didn't learn my calculus class, just simply multiplying this figure by 2. So it simply be 100 minus what? 8Q. This is called your margin revenue. If they ask you to maximize your revenue, you equate your margin revenue to 0. So 100 minus 8Q, put 8Q here, put 100 there. We divide both sides by 8. What we get? 100 divided by 8 will give you 12.5.
4.5.
So this is your quantity that maximizes revenue. Your price we know was 100 minus 4Q. Where there's Q, you put 12.5. When you subtract it from 100, we get 50. This is what we call revenue analysis. So I'll ask you now a question. Suppose our P is 50 minus 2Q. Who wants to find our total revenue? How to find total revenue?
To find total revenue, we multiply quantity, which is Q, by the price that we've been given, which is 50 plus 2Q. So it will be 50Q minus 2Q squared.
Correct. Who wants to find our average revenue?
Minus 2Q.
Average revenue is simply the price, which is 50 minus 2Q, correct. Want to find the marginal revenue? How do you find the marginal revenue?
DTR DQ.
The shortcut before we go to that one.
Okay, so can I try? Yeah, so you just find the change, the change in
not that one. I know
revenue. Oh, not okay.
Just multiply this one by 2, the gradient here by 2.
Oh, okay.
So this is what? 50 minus what? 4Q.
Where is the 2 coming from?
I mentioned that the formula for marginal revenue, alternatively, the linear function is A minus 2BQ, part of the formula. So now 50 minus 2, just multiply 2 there, to be 4Q. You tell me if our P was what? 50 minus 6Q, what becomes our marginal revenue?
It will be 50 minus 12Q.
Excellent. What was that? So you can prove that with your calculus as well. I'm mindful that others have not done calculus. I'll teach that one Tuesday, or maybe at 17. This is our marginal revenue. Just multiply that. But just for purities, for those that are curious, our total revenue was what? 50 Q minus 2Q squared. When differentiate this, we're going to get 50 what? This one we're going to get 4Q. This is our marginal revenue. Is it the same as what we got here? Absolutely. But D, how to maximize revenue? What do we do? How do we maximize revenue?
equate the marginal revenue to 0.
Should be equal to 0. So we equate this. Of 50 is equal to 4Q. So Q will be what? 50 divided by 4. What do we get? 12.5. 12.5. Put it in the price. What are we going to get? 50 will be 25. Okay. So with that said, I'll ask you to try your homework to calculate and maximize our demand function. This function, you find the marginal revenue, average revenue, and maximize revenue. So you can try this on your own. So I'll end here.